Right? You were given an initial amount, an initial investment of 80,000, the interest rate, the T, and you had to do it twice. Right? Once was going to use the formula for number of compoundings per year. The other one was for continuous. And you were given the formulas. And a lot of you actually plugged in everything correct and then got a wrong answer, which again shows me that all those times when we were doing those, I'm saying, do it, actually do it. Make sure you're getting the right answer when you do this. You didn't do it. You just sat there. Right? Again, you don't want to find this out on the test that you actually don't know how to plug an exponential into the calculator. Right? Don't make that mistake. You're given plenty of opportunity to practice this and make sure you could get it right. This formula on this side is A, P, E. Oh, that's wrong. P times 1 plus R over N to the NT. For this problem, it's just a calculation. It's not a solve, right? It's just plug it in and calculate. 80,000, 1 plus 0.035 divided by 12 for monthly compounding to the NT, which is 12 times 5 years. Okay. So just to show how we would have put it in the calculator to make sure that it's right, you can leave it like, you don't even have to like simplify this 1 plus 0.035 over 12. You don't need to do that. You could put it in the calculator just as it looks right there with one possible exception. 80,000 parentheses 1 plus 0.035 divided by 12 and raised to the power, meaning the hat key right there. And here's the possible exception. If you got an 83, you need to put what follows in parentheses. If you got an 84 and it pops you up into the exponent, then you don't really need the parentheses at that point. You could also just like do the math in your head and say 60. Just put in a 60 and you wouldn't have the same issue anyways. I'll put in 60. Okay, enter. Right, that was $95,275.43. Okay. I was listening to some other teachers talking about doing these kind of problems, and they were really bent out of shape over like how many decimals do you show for this kind of problem, because what does this represent? What's the unit? It's money, right? So it really makes sense to cut it off at cents, right? I mean, you would go to 0.43 for 43 cents and leave it at that because it's money. I never make that big of a deal of it, right? Now, okay, let me write that down. 95,275.43. 95,275. Come on. I think I got like a dead spot on the board that causes all the trouble. Holy mackerel. Okay. 0.43. Now, on this one, we're going to do A equals PE to the RT, because that's the formula we use when it's continuous compounding. And remember what continuous compounding is. It's like the limit of how much you can get out of this by just increasing the number of compoundings. Honestly, I keep meaning to look this up to see whether anybody actually gets continuous compounding or whether it's just like a theoretical thing for us to use in a math class. But we're going to plug in the P and the R and the T. That's it. So A equals 80,000 e to the 0.035 times T, which is 5. And again, I'll put it in the calculator. I'm not going to be able to see all that. Maybe I'll go like this. I can at least see the keyboard for now. 80,000 one more zero. Second, I'm going to use the e to the x, which is on the ln button. It's popping me in the exponent right there. And then, again, if you're going to do it with an 83, use a parenthesis, 0.035 times 5. Right. With 84, you don't really need to do that. Enter. 95,299.70. Okay. So notice that that number is more than, that number is more than that number, right? That's the limit of what you can get out of the compound. It's just a caution that there's a lot of you, like at this step right here, you simplified that, right? You did, which is, you would think it's okay to just put in the calculator 1 plus 0.035 over 12, and then you rounded it off and you put it in there, right? It makes your answer pretty wrong. In fact, it makes this answer more than that answer, which can't be right. It can't be right. Be careful with the rounding off too much in that step, because when you raise something to a really high power, like 60, right, a little difference is going to become a really big difference, right? And you don't want to give an answer over here, which is actually more than it theoretically could be, right? That's the limit of it over there.